Here's a linear inequality for us to solve. Again, it's linear because the exponent is 1 on the variable. And it also happens to be a combined linear inequality, meaning we are trapping the values between two other values. So we're only looking for the x values that will keep this quantity greater than 1/3, but at the same time keep it less than or equal to 2/3. Well, the beauty of a combined linear inequality is that we can attack it the same way we attack a simple linear inequality. And remember, that is done by solving it as if it was a linear equation, only watching out that if we ever have to multiply the inequality by a negative or divide the inequality by a negative, we have to switch the inequality sign. So if this was a linear equation, I would get rid of the fractions first. And as a linear inequality, I'll do the same thing. So in order to remove the fractions here, I need to multiply everything by 6. So I'm going to multiply each portion of this combined inequality by 6. Before I multiply, I always reduce. 3 goes into 6 2 times. So what's left is 2 times 1, which is 2. 2 goes into 6 3 times, so what's left here is the 3 to be multiplied times both of those terms. 3 times x gives us 3x. 3 times plus 1 gives us plus 3. 3 goes into 6 2 times. 2 times 2 is 4. So I've removed the fractions from the linear inequality, which is what I would do if I had a linear equation as well. Now, I want to isolate the x. So I want to get rid of this extra 3 term. So I'll subtract 3, but then I'll have to subtract it from the other 2 portions of the linear inequality, the combined inequality. So here, 2 minus 3 gives us -1. Plus 3 minus 3 is 0. 4 minus 3 is 1. And lastly, I want to have the coefficient of the variable to be 1, so I'll divide every portion of the linear inequality by 3, so that gives me x. X is greater than -1/3 and less than or equal to +1/3. So any value of x that's bounded by these values will make the original inequality true. If we took a value that was here in this interval, say the value of 0. 0 plus 1 is 1, and so that would give us 1/2, and 1/2 is greater than 1/3, but at the same time less than or equal to 2/3. So this interval of values defined by this inequality will cause the original inequality to be true. So they are the solutions to that original combined inequality.